Good morning, ladies and gentlemen of Algebra 2 Honors. We worked out number 10 yesterday, and we see kind of what happened here. Basically, it's taking these reference points, -1, comma, -1, 0, comma, 0, and 1, comma, 1. And basically, we're making a transformation. In this case, what kind of transformation was involved in problem 10?
Vertical stretch.
A vertical, I'll say compression, right?
Compression, right?
It's vertical by a compression, right? Compression by a factor of 127. Okay, what I'm going to do is I'm going to call on a volunteer, or will actually be voluntold, to do number 11, right? So have you done number 11 yet?
So it's a vertical. What?
You can. This table kind of gives you a clue of how to do it, right? On number 10, you kind of see. You kind of see what happened on number 10, don't you? You remember that from yesterday?
So what's number 11?
It's a verb compression of 1/3.
All right, let's go ahead and choose somebody from our famous wheel. Where's our wheel here? Come on, show up.
But it's not me. I hope number 11 is me, sir.
Okay, here we are. All right.
Amazon. Who's Amazon?
Dang.
Who's TMS?
Who's Amazon?
Who's TMS?
Here.
Oh, that's me, guys. Sorry.
And who's Amazon?
Who's Amazon?
Who's Amazon?
Mr. G, is that me?
Who's Amazon?
Yeah, that is you.
Amazon. There we go. We got Amazon right
Who's
there.
TMS?
Why are you
You ever heard of an Amazon Kindle? Amazon.
Oh. Mr. G, why's my name not up there?
It is.
That makes so much.
You're
It's
TMS.
I got something from
TMS.
Amazon.
Too much. You don't get
Sauce.
TMS? You
Too
don't
much
get that?
sauce or what?
Too much sauce.
Too much.
No. Texas Motor Speedway.
Oh.
Okay.
Yep.
All right.
I don't get
What's
it.
my name? I want a name.
Because you're fast.
No, because he's slow.
Because my name is going to be Talladega. All my brothers are named after cars.
I am.
Anyway.
Oh, Rich is coming today.
All right, Kendall. Back to class. We've had a little fun.
Wait, oh, wow.
You're
I'm glad we got a little reaction out of the names. Okay.
How do you make
I'm gonna name
All right, Kendall, what do we got? Or Amazon, excuse me. What Amazon? What do we got here?
vertical compression of 1/3.
Oh, yeah.
Oh.
Oh, yeah.
Okay, so what it is, it says identify the transformations. So we call this so we know what it is. So we're going to go ahead and transform these points here. So what do we go ahead, what are going to be these points transformed here?
I don't know.
Yeah.
Amazon.
Is it gonna be
It's going to be 1/3.
negative?
What are the points?
Okay, Amazon, here we
Girl,
go.
now Amazon.
Amazon.
Amazon Prime?
You just confused.
She doesn't know.
So what we're going to do is we're going to go ahead and take these and transform these reference points.
Would it be a
And so what we're going to do is we're going to take this -1 and plug -1 into this function. So if we plug -1 into this function, what do we get as an output here?
one?
Negative 1/3.
Thank you, Amazon.
Amazon.
And does 0 change?
No.
Oh,
Okay, what
Amazon.
is this next one here?
Braden, are you Amazon?
It's 1/3.
1/3.
Okay, 1/3, right? So now we're going to go ahead and mark these points right here. So there's the translated reference point, and this one here is translated to nowhere except where it was originally. And so now we can go ahead and sketch a curve of this, right?
Yeah.
And I don't know if I mentioned it in this class, but this thing right here, what did we call this?
Point of
Point of inflection. Did I mention it yesterday?
Yeah.
Point of inflection. I did, okay, point of inflection. Okay, what I want you to do is go ahead and look at number 12. And as you can see, the number 12 is not gonna be the same type of problem exactly.
So we don't have to do the table?
I would actually do a table in number 12 and 13, because I think it'll help you organize where your reference points go, because you still gotta take those reference points and move them, and change them according to
So you just put them.
what that was.
My name is TMS.
It's TMS.
It's better. It's better right now.
I guess by negative 1, 0, 1.
So it'd be
That's what I said.
x negative 4.
Oh, my.
It'd be
Oh, my.
what's negative 4 cubed?
Oh, my.
At negative 128. Is that right?
I don't know.
Yeah.
Will the first one be negative?
Huh?
Will the first one be? That's why
No, no.
you get a 67.
Negative what?
Oh, no, no.
All right.
So how do I do the table?
Didn't know the exact.
But how do I-
All right, let's go, because people, you guys are talking through it pretty well, I think, so.
What's negative 1 cubed?
I'm saying I don't know.
I'm so sorry.
Take it.
And whoever it is, if the first person struggles with number 12, I'll help somebody if I need to.
No. I swear.
That ain't me.
Bryce.
Oh, you got one.
Put it in.
Yes.
All right, Bryce, what do you think?
First one, no.
I don't know how to do it.
Translate it for me.
It'd be negative.
Okay, let's go ahead.
Negative 1 to me.
All right, Bryce.
Well, I don't know.
Negative
So
1.8.
you're making 10.8.
Couldn't we do it with tables?
Because negative 5 squared, negative 5 cubed.
Negative 5. You?
I can play negative.
Let's get negative 5.
Put it in the line.
Because you plug in 1 for x.
What would be negative 30?
So we're gonna go ahead and change this.
Or, yeah.
And so Bryce, so we have x, g of x, right?
Right.
Yeah.
Okay, what does this function do to the original? And we can actually, we'll start with this 0 here, right? What does this do to the x values?
Translate
It
to
changes
the
it.
to the left.
It goes to the left.
No, it goes to the right.
Right.
To the right, okay? So let's take, so Bryce, I want you to take negative 1 and add 4 to it.
So would it go down
It'd
3
be-
units?
it just go to 3.
This will go to 3, right?
Mm.
And this one here will go to
4.
4, and this one here will go to
5.
5. All right?
Yeah.
Okay, good. Now, what I want to do is, what is the overall translation of this thing, Bryce? We know we translate, you said 4 units to the right, we know that, right?
Right.
Any other translation going on besides 4 units to the right?
Down 3.
Down 3 units, all right?
Yeah, Bryce.
All right, good.
Good job, bro.
So what we've done is we're taking this point here, this point here, and this point here, and we're moving 1, 2, 3, 4 units to the right. So it's going to look like that, right?
Right.
And then we're going to move, how many units down? You said 3.
3.
So 1, 2, 3. So which points are we talking about? Well, we're talking about this one here, right? And this is this point translated this way, right? So what's gonna go over here?
3, negative.
Negative 3.
Let me go ahead and get this here. Thank you, Bryce.
Yep.
Okay, now the real Bryce. Okay, which one's gonna go here? Now remember, it's gonna be this point here.
That's a frac, that's a decimal.
Well, see what it is that's really, okay, it's supposed to be like this more, that's a better translation there. Okay, so it's this point right here. Which one is that, Bryce?
-4.
So -4, you say? Okay. And this one here is gonna be,
-2.
-2, okay. Everybody agree with that?
Yeah.
Did it help to drag the curve like that? To see where it is? Of course, you don't have the tools to do that as easily on your paper, but you can see it's a doable thing, right?
Yeah.
Okay, I'm gonna call on somebody here shortly for number 13. Thank you, Bryce.
No problem.
Okay, let's go to, yeah. Right, here we go. Shuffle once.
Hopefully it's TMS.
No.
It'll be Haley.
Haley.
This thing used to not pick Haley very much, and now it's got Haley a couple days in a row. Kind of make it up for lost time. All right, Haley, what do you got?
I did the.
You did a table? So did you do like this, made an original table,
Yes.
like x f of x? Like this? Okay, and then you made a translation, is that what you did?
Yes.
Okay, what did this thing translate over to?
I put -2, -3, -4. And then on the other side, I would finish it.
Wouldn't it be 0?
It'll be -1, 0.
Just go to the left.
Sure.
Okay, remember we're shifting these, which way are we shifting these?
To the left.
How many units?
1.
One, okay? So I'm seeing this one here, right?
I don't know.
But I'm not seeing these others.
Oh.
What are these ones gonna be here?
-1 and 0.
Okay?
So,
Right, so we've taken these things and we've moved them over to here.
Remember, Mr. Chambers?
Here,
No, man, Harold.
here, go ahead, David.
And on here, I put it 1, 2, 3.
yeah, right.
Separator.
What goes here?
Dude, it's because I'm in.
1, 2, 3.
I think, I don't know if I did it right.
Okay, you have to add 2. So it's taking these and adding 2, right? I think you're right. I think it is right. 1,
Is that a turtle?
2, 3. Let's try it out.
You were totally off.
So what I'm doing here is I'm sketching over the curve like this,
Yeah.
okay? And now we're gonna move, you said Haley, 1 to the left, is that right? And then which way? Up 2? So something like this.
Okay.
So you should get -2, 1. Is that right? -2, 1, is that right?
Yes.
And you should get -1, 2, is that right?
Yes.
And then finally 0, 3, is that right? Yeah, so they look good. So that's it. Okay. What I want you to do is get out ready to take some notes. We're gonna go ahead and, explain what it is here in half a minute.
You gonna pick us up?
Yeah, go ahead. So you get that up.
You cute.
I got another present.
It's not my name though, but
Friends want you that.
My good friend.
I wanna be their friend.
Do you? No. His name is Juan.
What did you buy
His
him?
name is Juan.
Okay,
$50.
You want you $200
I
invoice?
gave him his gift card. I have to be $100. No, you don't have swoosh.
He left salt and pepper open, and I don't see the table. And I was like, only no pepper and then damn one.
My AirPods won't work.
So I made it.
So you fix my AirPods.
We're working on Mexican.
okay, class, let's bring it back.
you have to do notes, guys.
Let's bring it back here.
You gonna go back?
Maybe.
Okay, is everybody with me, right?
Yeah, everybody's
Everybody's
here.
with me.
Everybody here?
Okay, here we have 6.2, graphing polynomial functions. Such a question, how do you sketch the graph of a polynomial function in intercept form? And what happened is, I like to call this intercept form, I call it factored form. Factored form instead of intercept form. It's just, to me, I think it's a little more descriptive of what this actually is. But we'll talk about that. Okay, and then we have this teak here, write the domain and range of a function in interval notation. So let's go ahead and look at what's going on here. Okay. Explore 1, investigating the end behavior of graphs of simple polynomial functions. And here we have sort of a brief, maybe not so brief explanation of what's going on here. Linear, quadratic, and cubic functions belong to a more general class of functions called polynomial functions, which are categorized by their degree. And here, linear functions are polynomial functions of degree 1. Quadratic functions are polynomial functions of degree 2, and cubic functions are polynomial functions of degree 3. And then they give this general polynomial function of degree n they give this sort of textbook formula for standard form of polynomial function. And then it says, note the constant term, a sub 0 appears to have no power of x associated with it, but since x to the 0 power equals 1, you can write a sub 0 is a sub 0 times x to the 0 power and treat a sub 0 as the coefficient of the term, which is, a coefficient is just a what? Somebody said it really quietly. Numbers, just the numbers. Who said that? Somebody said quiet.
Randy.
Just the number, okay? Okay, and then other pieces of vocabulary we haven't addressed yet are these here in the last paragraph. A polynomial function of degree 4 is called a quartic function, Q-U-A-R-T-I-C, and while polynomial function of degree 5 is called a quintic function. And I want to show you something that might help you remember what those are. Where do you think I will show you that?
On a graph.
I will show you a calculator. I'm going to go to Stat,
Edit.
and I'm going to go to Calc. And here, they have you, 7 is a quartic regression, which is a fourth power. So it's sort of logically here. First power, second power, third power, fourth power. I don't think they have quintic in the menu here for this type of calculator, but you can see that.
Cubic be 3.
Cubic is third power, yes. Exactly right. So Marcus reminds us that cubic is third power, which is what we just, and here he says, cubic functions are polynomial functions of degree 3. So we're going to go ahead and go over this table, which is going to summarize some of these things, and we're going to make this pretty brief today. Function, and so these are all what we would call parent functions for these different powered polynomial functions. And one thing they don't have is they don't have written up here, I'm just going to draw it in here, which is f of x. So I'm making like an extra, f of x equals x to the 0 power. Okay, that's another one that's not on here. So here with the one I drew, x to the 0 power, then you have x to the, what power is that? First, second, third, fourth, fifth, and sixth. So you see all those, right? So what is our domain of all these? Yeah, domain is, Braden said, all real numbers, right? So domain is going to be this. And what is the domain going to be for everything here? Same, right? So what I'm going to do to abbreviate things, I'm just going to go ahead and do this. Because the domain of these and all other polynomial functions is all real numbers. Thank you. Okay, now we're talking about range, which is the next column. In range, what is our range of this one right here? X to the 0 power. This is a really weird one. Okay, this one here, I'll give you the hardest one first. The range is going to be this right here. I'm going to write it right here. That is our range of this f of x equals x to the 0 power. Right, so what is that going to look like when we graph it?
It's like that.
Yeah, let me show it. In fact, I'll show you. So I think Siggy is making the hand motion, right? So if we go ahead and graph this as x to the power of 0, we should see, okay? And so our range is 1, which in interval notation is bracketized 1 comma 1. Okay, now this next one, x to the first power, where's our range of that one going to be? All real numbers. Okay, and then for f of x equals x squared, where's the range of that one going to be?
Wherever it ain't going like that, so it has to be like a certain number.
Yeah, so what this one's going to be, this one's going to be like this.
Oh yeah.
And then if you kind of look at this, there's sort of a pattern. This one here is negative infinity, comma infinity. And this one here is x to the 4th power. We have that. And then we have, so all real numbers here. And lastly, we have x to the 6th power is going to be like this, right? So you see the pattern here. And then the last column deals with end behavior. As x approaches positive infinity, f of x approaches, well, yeah, for this one here, it's going to be f of x approaches 1. Okay, so this one here, as x approaches positive infinity, f of x approaches 1, and same for negative infinity. Now for this one here, f of x equals x, as x approaches positive infinity, f of x approaches, okay, infinity, and then as x approaches negative infinity, f of x approaches negative infinity. And now for this x squared, as x approaches infinity, f of x approaches, okay, remember we're talking about, I'm going to draw a little sketch here. Okay, we're talking about this one right here. Okay, this is what the sketch of the thing is going to look like, right? Okay, as f of x approaches infinity, f of x approaches infinity. And then for the next one, as x approaches negative infinity, f of x approaches infinity also. Thank you, good job. Okay, so, and then we can go down the list here. Here we have this one. This is the last section we just did with Kindle's problem and everything, right? Where we have this looking thing here. So as x approaches for this x cubed, as x approaches infinity, f of x approaches infinity. And as f of x approaches negative infinity, as x approaches negative infinity, f of x approaches negative infinity. And so you have, don't you, kind of an alternation. And here for the x to the fourth power, we have infinity, infinity. And here we have infinity, and down here, negative infinity. And then finally here we have infinity, infinity, right? Okay, let's see here. Okay, that's more or less what it was, right? Sideways eights, they're hard to draw.
Yeah, mine didn't pick up.
Okay, very good. Any questions on those? Okay, did I talk about odd, positive, odd, negative yesterday?
Yes.
I did, right?
Yeah.
So these ones here, 1, 3, x to the first, third, fifth, are going to be odd what? Odd, positive, right? And these other ones, squared to the fourth power, x to the sixth, are going to be what?
Even.
Even positive. Even positive. Okay. Now the next sheet is the very same table, except with one key difference. We'll see what this is. Okay, you see that it's the same thing, except, are these parent functions here? No, they are not, right? These are what? F of x equals negative x squared, negative x cubed. But what is the domain of all these still going to be? Domain's still going to be this. And I just want to do a couple of these. The range is going to be same, right? And then what is our range of this thing going to be? Negative x squared.
Negative infinity, 0.
So Braden, you're saying like this? Yeah, in our end behavior, as x approaches positive infinity, f of x approaches
Negative infinity.
negative infinity. As x approaches negative infinity. So for the squared, we have starts low, ends low, right? Or the negative x squared. So that's going to be what? Is that going to be even?
Yes.
But even, negative. Starts low, ends low. Okay, starts low, ends low. Negative. And so, but basically it's the same type of thing. Now qualitatively, how do these look different? I'm going to draw this one I'm gonna draw negative x squared, it's gonna look something like this. Okay, compared to negative x squared, what is negative x to the fourth gonna look like? How's it gonna be different than x squared? Two things. It's gonna be a little steeper, and it's going to be smashed a little flatter against the x-axis. So it's going to be kind of a little more rounded here, so it's going to look something like this. And negative 6 power is even going to be a little more, it's going to be a little steeper and even a little flatter against the x-axis here. You see that? And we're just going to show on the calculator here. I'm going to put down negative x to the 6th, and we will see that. So you see that? Steeper and smashed flatter against the x-axis. All right? But generally, it takes sort of the general form of a parabola, doesn't it? Kind of. So it's sort of like a parabola. I'm going to put negative x squared so you kind of see the contrast here in lavender. So you see, here's the negative x squared, and the blue one is the negative x to the 6th.
What if you put it like a greater?
Even a greater exponent? Yeah, so Marcus, so you can experiment with this, and we can do is we can change this.
So like 28.
Yeah, we can change it to 28, you say?
Yeah.
We'll see what happens here.
From that line.
So it's even more pronounced, isn't it? So it's almost just like a rectangle, is what it looks like. So that was a good idea, Marcus. That was a very good idea to see what happens. But you could kind of see as the thing was smashing flatter that it was going to sort of go in that direction, couldn't you? That was a good idea. Okay, I'm not going to go into any more of these. I think we've kind of gone through this. Let's just go on to the next thing here. Okay. Okay, generalizing. Let's not do this. Okay. Now we're going to talk about this right here, the function and factors here. So here we have functions. This table of functions. We have, it says here, use a graphing calculator to graph cubic functions, and we have 3 cubic functions here, and then use the graph each function to answer the question, and we'll just get as far as we can in 5 minutes. How many distinct factors does f of x have?
3.
Well, this one here, f of x equals x cubed, has just one distinct factor.
Oh yeah.
In other words, that we have, it's x times x times x, which are the same, it's the same thing to the power of 3, right? So we have one distinct factor, and on this one here, f of x equals x squared times 20x minus 1, how many distinct factors do we have here? We have 2. And then this last one here, f of x equals x times 20x minus 2, x plus 2, we have how many? We have 3
I'm seeing a pattern.
Whoa.
patterns. And then it says, what are the graph's x-intercepts? Where the graph touches or crosses the x-axis. Do you have that on your calculator?
Yeah.
Yeah, it's like a.
So what are the graph's x-intercepts here for this one, f of x equals x cubed?
0.
Yes, so we have x is equal to 0. That is our x-intercept. We only have one x-intercept, right? Now this one here, this next one, where are the x-intercepts?
Nice. -2.
Like a.
Like a
It's 2.
-2 or 0.
Okay, you just says use your graphing calculator. Let's see.
Is it 0 and 2?
0 and 2, thank you.
That's it.
And then this last one here, for this last function here, where are the x-intercepts?
0, 2, and 8.
X equals 0. I'm just going to say x equals plus or minus 2.
Yeah. Yep.
Okay, so I just a little abbreviated.
We got 3.
Yeah, this one has 3 x-intercepts, this last one here.
Yeah.
And remember it said at the beginning, it said intercept form? This one right here, I like to call this factored form. Because what you have, if we expanded everything out, we would get x cubed, we would get, and so forth. But in factored form, you just write these as factors. Okay? And then what's going to happen is the graph tangent to the x-axis, or does it cross the x-axis at each x-intercept? Well, here, if we graph this thing, and we looked at this in our earlier exercises, is we had something look like this. Is the graph tangent to the x-axis? It actually is, because it's briefly horizontal. If we go back to our calculator and look at it, and we put okay, we go ahead and put x cubed. What this does is the thing kind of jogs like this and is momentarily, right where x equals 0, tangent to the x-axis, but also being tangent, the graph also does what besides go tangent? It crosses. So does it cross the x-intercept? So yes, crosses. And tangent. Crosses plus being tangent. And here for this one here, does this, we have x squared times x, let's see. So we have, I'm just going to go to this one. So we have x squared times quantity x minus 2. Okay, so we graph that, we get this. Okay, for the 0 here, are we tangent at 0? Yes. Are we crossing at 0?
Yeah.
We are not crossing. We just touch and then go back up. Do we cross at x equals 2? Yes, we do. And so we say, is the graph tangent? Here, it crosses, we'll say crosses at x equals 2. At x equals 2, but just touches at x equals 0, right?
Yeah.
Touches at x equals 0. And then right here, what do we have for our factored form? Well, what we're going to have is, and we'll probably finish on this one today. Okay, this one here we have x times quantity x minus 2, x plus 2. And we didn't quite get to the turning points today. We'll probably start talking about turning points tomorrow. But you see what happens here? We're crossing everywhere, right? Okay, crosses at all zeros.
Wouldn't it cross at the same x as the top?
They're crossing everywhere the zeros are. -2, 0, and 2. So we just need to leave it there today, ladies and gentlemen.